In the time it takes for your eyes to adjust to the dim light of this room, and for your breath to find its natural rhythmic pace, a silent messenger from the edge of creation has traveled millions of miles closer to us. This video is an invitation to leave the weight of the world behind and drift into the velvet embrace of the cosmos as we embark on a journey through every galaxy in our observable universe. We begin our ascent at the very threshold of the unknown, where the latest eyes of humanity have peered into the darkness and found that the universe is far more crowded, far more vibrant, and far more mysterious than we ever dared to imagine. For generations, we looked up at the night sky and felt a sense of overwhelming scale, yet even our most professional estimates were merely scratching the surface of the truth. By 2024, the scientific consensus held a firm, almost comfortable number in its grasp. We believed there were roughly 200 billion galaxies in the observable universe. It was a number large enough to inspire awe, yet small enough for the human mind to categorize as a finite, albeit massive, collection. We spoke of these 200 billion islands of stars as the sum total of our cosmic heritage, but then a new sentinel was awakened in the cold, silent reaches of space, the James Webb Space Telescope. When its gold-plated mirrors unfurled and its infrared eyes turned tea-houred the deepest shadows of the void, the reality we thought we understood was shattered. The number didn't just grow, it exploded by a factor of 10. We now know that the observable universe is home to at least 2 trillion galaxies. Think for a moment about what that truly means as you sink deeper into comfort. For every single galaxy we thought existed, 9 more were hiding in the cosmic shadows, whispering their presence through light so faint and stretched by time that it was invisible to every instrument ever built by human hands. These are the ghosts of the deep galaxies, so distant that their light has been traveling toward us since the universe was a mere fraction of its current age. We are no longer looking at a sparsely populated void, we are looking at a cosmic ocean teeming with life, energy, and structure, where every patch of apparent emptiness is actually a window into a trillion different worlds. The scale is so immense that it transcends mathematics and enters the realm of the sublime, a realization that our previous perspective was like looking at a single drop of water and assuming it represented the entire sea. This revelation was made possible by a shift in how we perceive light itself. As the universe expands, it stretches the light traveling through it, pulling it from the visible spectrum into the long, cool waves of the infrared. To our eyes, these distant regions looked like a black wall, a final boundary of nothingness. But through the infrared veil, that wall has dissolved. Where we once saw a vacuum, we now see the red monsters and the cosm, icy infants, galaxies that formed so early and so efficiently that they challenge the very laws of physics we once thought were absolute. In the time it takes you to blink, light from thousands of these newly discovered systems crosses another mile of its multi-billion-year journey toward Earth. Some of that light began its flight before our solar system was even a cloud of dust, before the sun had ignited its first fire, and before the Earth had even been dreamt of by the forces of gravity. As we drift further into this realization, let your mind settle on the sheer density of this new universe. If you were to hold a single grain of sand at arm's length against the night sky, the tiny patch of darkness it covers would contain not just a few stars, but thousands of entire galaxies. Each of those galaxies is a swirling metropolis of hundreds of billions of suns. Within each of those suns, planets are likely orbiting in the silence. On some of those planets, perhaps the same elements that make up your body are being forged or have already given rise to civilizations that looked out at their own sky and wondered about us. Cosmic math becomes a lullaby of infinite possibilities. 2 trill. Lion galaxies mean that the number of stars in the observable universe is roughly 200 sexillion, a 2 followed by 23 zeros. It is a number that exceeds the grains of sand on every beach, every desert, and every sea floor on our planet. This first chapter of our journey is about surrendering to that scale, We are moving past the era of the empty universe and into the era of the infinite tapestry. The James Webb Space Telescope didn't just find more objects, it found a different kind of history. It showed us that the early universe was a place of frantic, brilliant activity, where galaxies were being assembled with an efficiency that seemed almost impossible. These baby pictures of the cosmos are not quiet or still. They are portraits of a time when the universe was emerging from its dark ages, ionizing the surrounding hydrogen and clearing the primordial fog to allow the first light to shine through. As we fly through this infrared veil, we are moving backward through time, watching the structure of reality build itself piece by piece. The beauty of this discovery is its silence. Despite the unimaginable speeds at which these galaxies are moving and the vital NT energy being released in their cores, the view from our perspective is one of perfect, crystalline peace. The light reaches us as a gentle shimmer, a soft glow that carries the weight of 13 billion years of travel. There is deep security in that distance. We are tucked away in our own corner of space, watching the grandest show in existence from a place of absolute stillness. The 2 Lion-fold reveal is not just a scientific update, it is a shift in the human soul. It reminds us that no matter how small we may feel, we are part of a system so vast and so intricate that even the darkness is full of light. The infrared veil was the last great barrier to our understanding of the cosmic dawn. By peering through it, we have found that the universe did not struggle to create life and structure. It flourished from the very beginning. The galaxies we see in these deep fields are not just dots of light. They are the ancestors of everything we know. They are the crucibles where the oxygen in your lungs and the iron in your blood were first imagined. As you continue to listen, let the image of these 2 trillion islands of light fill your inner vision. See them as a glowing net, cast across the infinity of space, each one a testament to the enduring power of gravity and time. We are no longer lost in the dark. We are simply beginning to see how bright the dark has always been. The journey ahead will take us through collisions that last for eons and voids that stretch for hundreds of millions of light years. But for now, stay here in the light of the 2 trillion. Feel the expansion of your own perspective. As the boundaries of the known universe are pushed back farther and farther, the weight of your daily life is a tiny speck compared to the glow of 1 trillion suns. And in that comparison, there is a deep, restorative rest. You are a conscious observer of a universe that has finally decided to show its true face. The veil is gone, the stars are waiting, and the seed has just begun. To truly understand the vastness we are navigating, we must first look at a single point of darkness that changed human history. This chapter is a meditation on the power of patience and the rewards of looking where others see nothing. Imagine, if you will, a tiny patch of the night sky, located in the constellation of Fornax. To the naked eye, and even to most ground-based telescopes, this region appeared to be an absolute void, a cold, empty corridor of nothingness. But in the late months of 2003, astronomers decided to perform a radical experiment. They pointed the Hubble Space Telescope at this specific, seemingly vacant spot and let it stare. They didn't just look for a few minutes or hours, they kept the telescope's shutter open for a total of 11 days, accumulating over 800 separate exposures. This became known as the Hubble Ultra-Deep Field, and it remains one of the most profound images ever captured by our species. It is the story of how a grain of sand held at arm's length can contain the history of the entire world. As you settle into your blankets, visualize that grain of sand. If you were to hold it up toward the sky, the tiny area of the universe it would block out is exactly the size of the patch Hubble studied. It is a space so small it seems insignificant. Yet, when the data was processed and the light was finally revealed, that empty patch was found to be teeming with over 10,000 galaxies, 10,000 entire worlds, each containing billions of stars, were hiding behind a space no larger than a speck of dust. This was the first time humanity truly grasped the density of the cosmos. We realized that we are not living in a dark room with a few scattered lamps, but in a grand cathedral where every square inch of the walls is encrusted with diamonds. The Hubble ultra-deep field didn't just show us what was there, it showed us when it was there, because light takes time to travel. Looking deep into space is exact. Like looking back through a calendar of time. In this iconic image, we see a chaotic and beautiful timeline of the universe's life. The larger, more defined spiral and elliptical galaxies in the foreground are the adults of the cosmic family, appearing as they were only a few billion years ago, but behind them, smaller, redder, and more distorted smudges represent the universe in its teenage years, and even further back, the tiny blue specks are the infants, the very first galaxies to ever ignite. These primordial systems were formed less than 800 million years after the Big Bang. They are irregular and messy, pulling themselves together from the raw gases of the early cosmos. They are the pioneers of light, the first structures to break the silence of the Dark Ages. Listening to this, you might feel the immense weight of time, a slow-moving river that has been flowing for 13 billion years just to reach your eyes and ears tonight. There is a strange comfort in knowing that even the most distant, ancient light has a destination, and right now, that destination is you. The legacy of the ultra-deep field is a lesson in perspective. It tells us that our local environment, the stars we see with our eyes, is just a thin veil over a much deeper reality. Every direction we look, if we look long enough and with enough sensitivity, we find an endless corridor of galaxies stretching toward the horizon of the Big Bang. The image revealed that galaxies are not static, they are dynamic, growing through collisions and mergers. We see galaxies in the process of tearing each other apart, their stars being flung out like glowing spray from a crashing wave. We see the intense blue glow of massive star-forming regions where new suns are being born at a rate that would be impossible in our modern Milky Way. This is a universe of constant movement, yet from our distance, it appears as a frozen masterpiece of light. A silent testimony to the endurance of matter. Think of the patience required to capture such an image. 11 days of staring into the dark. It is a metaphor for the human condition, our desire to find meaning where there appears to be none. The scientists who designed this study were taking a risk. They could have found nothing. But the universe is generous to those who look closely. By committing to the darkness, they found the light of 10,000 civilizations. As you drift closer to sleep, let the scale of this realization soothe your mind. The problems and worries of a single day, or even a single lifetime, are like shadows passing over a grain of sand. Beneath those shadows lies a reality so vast and so full of light that it defies description. The Hubble ultra-deep field is our bridge to that reality. It reminds us that we are part of a continuous story that began in the deep past and will continue long after we are gone. The colors in this deep field are not just for beauty, they are the language of distance. The bluer galaxies are full of hot young stars, while the redder ones have had their light stretched by the expansion of space itself. This redshift is the heartbeat of the expanding universe, a constant stretching of the fabric of reality. We are witnessing the expansion in real time as we fly through these layers of history. Imagine yourself drifting past these 10,000 islands, moving deeper and deeper into the photograph, past the spirals, past the ellipticals, until you are surrounded by the faint blue glow of the very first stars. These are the ancestors of every atom in your body. They lived fast and died in brilliant explosions, seeding the universe with the elements that would eventually become planets, trees, and people. You are looking at your own origin story, written in the oldest light in existence. The ultra-deep field also taught us about the great observational democracy. It showed that no matter where you point a telescope in the sky, the universe looks more or less the same. E is no special center, no privileged position. Every observer on every planet in every one of those 10,000 galaxies would see a similar deep field if they looked long enough. We are all linked by this shared cosmic horizon. This realization brings a sense of profound unity. We are all passengers on different ships in the same vast ocean, all looking out at the same distant lights. The isolation we might feel on our small planet is an illusion. We are woven into a tapestry that spans the entirety of space and time. As this chapter draws to a close, let the image of that grain of sand return to your mind. It is no longer just a piece of earth, it is a portal. It is a reminder that the vacuum of space is never truly empty. It is a reservoir of history, a gallery of light that has been waiting billions of years for someone to notice. The Hubble ultra-deep field was our first real map of this gallery, a legacy that paved the way for every discovery that followed. It gave us the courage to look deeper, to stay longer in the dark, and to trust that the universe is always full of wonders, even when they are hidden from view. Now, as the light of these 10,000 galaxies begins to fade into the background of your consciousness, prepare yourself to move from the distant past to our own immediate neighborhood. We have seen the edge of the world, now it is time to look at the family of galaxies that call us neighbors. After traveling across the staggering distances of the deep field, where galaxies appear as mere pinpricks of light, we now pull back our cosmic focus to the space we call home. This chapter is an exploration of our immediate surroundings, a gravitationally bound family of cosmic travelers known as the local group. While the universe at large seems to be expanding and pushing everything away from us, here in our own neighborhood, gravity has won the battle. We are part of a small, intimate collection of more than 54 galaxies, all performing a complex and beautiful dance that has lasted for billions of years. As you breathe slowly and feel the weight of your body settling, imagine yourself at the center of this local cluster, looking out at the companions that share our journey through the infinite dark. 3 giants, surrounded by a swarm of smaller, loyal followers, all linked by invisible threads of mutual attraction, dominates our NEI. Neighborhood. To visualize the scale of our local neighborhood, imagine for a moment that our entire Milky Way galaxy was the size of a dinner plate. In this scaled-down reality, the local group would stretch across a distance of nearly 3 miles. It is a vast area, covering roughly 10 million light-years, yet compared to the immense filaments of the cosmic web, it is a cozy and familiar suburb. The undisputed queen of this neighborhood is the Andromeda Galaxy, also known as M31. Andromeda is a magnificent spiral, much like our own but significantly larger, containing over 1 trillion stars. It sits about 2.5 million light-years away, appearing in our night sky as a faint, fuzzy smudge. Yet it is currently racing toward us at 68 miles per second. For now, it remains a distant, glowing sister, its spiral arms spanning 220,000 light-years across. It is the most massive member of our group, exercising a powerful gravitational influence that dictates the movement of almost every other galaxy in the vicinity. The second major player in this dance is our home, the Milky Way. With our 300 billion stars and a diameter of 100,000 light-years, we are a formidable presence in the local group. We sit approximately 26,000 light-years from the galactic center, nestled in the Orion arm, watching the other members of our family from a position of relative stability. The third member of the Great Triad is the Triangulum Galaxy, a spiral about half the size of the Milky Way. Though it is smaller, Triangulum is a vibrant and active participant, birthing new stars at a rate that outpaces its larger neighbors. These 3 spirals, Andromeda, the Milky Way, and Triangulum, contain the vast majority of the mass and light in our neighborhood. They are the anchors of the local group, the celestial heavyweights that keep the entire structure together as we hurtle through the void. But a neighborhood is defined as each by its smaller inhabitants as by its giants. Surrounding the Milky Way and Andromeda are dozens of satellite galaxies, many of which are dwarf galaxies that orbit the larger ones, like cosmic pets. The most famous of these are the Large and Small Magellanic Clouds, visible to the naked eye from Earth's southern hemisphere. They appear as soft, glowing clouds of light, but they are actually irregular galaxies containing billions of stars. The Large Magellanic Cloud is a particularly chaotic and beautiful place, home to the Tarantula Nebula, one of the most active star-forming regions in our entire local vicinity. These satellites are not just passive observers, they are constantly being pulled and stretched by the Milky Way's gravity, losing gas and stars to our own galaxy in a process that will eventually lead to their total absorption. The dance of the local group is governed by the laws of gravitational attraction, which act like a cosmic glue. While the dark energy of the universe works to accelerate the expansion of space and push distant galaxy clusters apart, the gravity within the local group is strong enough to resist this pull. We are a bound system, destined to stay together even as the rest of the observable universe eventually fades from our view. This creates a sense of profound cosmic isolation and, at the same time, deep belonging. We are part of a small island of matter that will remain intact for trillions of years. Within this island, the motions are intricate. Dwarf galaxies like Leo I, Fornax, and Sagittarius move in looping, eccentric orbits, occasionally passing through the disks of the larger galaxies and triggering waves of star formation as they go. As you drift deeper into relaxation, imagine the silence of this local dance. There is no sound in the vacuum, only the slow, relentless pull of mass upon mass. We are moving through space at over 1 million miles per hour, yet within the local group, everything feels balanced and purposeful. These smaller galaxies provide a constant influx of new material for the larger ones, ensuring that the cycle of stellar birth and death continues. This neighborhood is our refuge, a place where the laws of physics have created a stable environment for life to flourish. The distances between these galaxies are vast, millions of light-years of empty space, yet they are connected by streams of invisible gas and dark matter that act as the highways of our local system. The local group is also a place of history and memory. By studying the chemical composition of the stars in our neighboring dwarf galaxies, astronomers can piece together the story of how our neighborhood was built. We find that many of the smaller members are relic galaxies, containing some of the oldest stars in the universe. EY are the leftover building blocks from the early days of cosmic assembly, preserved in the quiet outskirts of our group. Looking at them is like looking at the foundation stones of our own home. They remind us that the Milky Way did not appear in isolation. It was built through the gradual accumulation of these smaller systems over billions of years. We are a product of our environment, a galaxy, shaped by the neighbors that surround us. As we conclude this chapter of our flight, let your mind rest on the idea of this local family. The great spirals of Andromeda and Triangulum, the glowing Magellanic Clouds, and the dozens of tiny, ghostly dwarf galaxies are all our companions in the dark. They are the landmarks of our cosmic suburb, the only other galaxies we will ever be able to visit if we were to travel through space. The rest of the 2 trillion galaxies we discussed earlier are moving away from us, but the local group is our permanent home. It is a place of rhythmic motion, gravitational loyalty, and enduring light. Now, as the familiar shapes of our neighboring galaxies begin to blur, prepare to expand your mind once again. We are about to look beyond the local group to see a gargantuan architecture that holds our entire neighborhood in its grasp. As we pull further away from the familiar embrace of our local group, the individual galaxies that once seemed so massive begin to shrink, transforming into tiny glowing droplets within a much larger stream. This chapter invites you to expand your consciousness to a scale that was entirely unknown to humanity until only recently. We are leaving our local suburb to understand our true cosmic address, a structure of such staggering proportions that it challenges the very limits of our mapping capabilities. We belong to Laniakea, a name that translates from Hawaiian as immense heaven. It is our home supercluster, a vast, gravitationally connected network of 100,000 galaxies stretching across 500 and 20 million light-years of space. To visualize this, imagine the Milky Way not as a grand spiral but as a single microscopic spark of light, one of 100,000 sparks caught in a gargantuan shimmering web that resembles the delicate neural pathways of a brain or the branching veins of a leaf. In the silence of this immense heaven, we find that the universe is not a random scat, airing of matter, but a highly organized architecture. For a long time, we believed we were part of the Virgo supercluster, but in 2014, a team of astronomers redefined our boundaries. They discovered that the Virgo supercluster is actually just one small branch of the much larger Laniakea tree. This discovery was made by measuring the peculiar velocity of galaxies, the way they move beyond the expansion of the universe. By tracking how these 100,000 galaxies flow through space, scientists were able to map the gravitational watersheds of the cosmos. Just as water flows down a mountain and into specific valleys, galaxies flow toward specific gravitational centers. Laniakea is our valley, a cosmic basin where everything within its borders is being drawn toward a mysterious and powerful center known as the Great Attractor. The Great Attractor is a gravitational anomaly located roughly 250 million light-years away, possessing the mass of tens of thousands of Milky Ways. It is the heart of Laniakea, pulling our galaxy, Andromeda, and the thousands of galaxies in the Virgo cluster toward it at over 1,000 miles per hour. As you lie still, imagine this slow, relentless migration. We are part of a cosmic river, a silent procession of light moving through the dark. Yet, despite this high-speed pull, the distances are so vast that we will never actually reach the Great Attractor. The expansion of the universe acts like a treadmill moving in the opposite direction, ensuring that while we are drawn toward the center, the space between us continue to grow. This balance between the pull of gravity and the push of expansion creates the elegant, feathery structure of Laniakea, where galaxies are strung out along thin filaments that curve toward the central mass. Laniakea is more than just a collection of galaxies. It is a testament to the interconnectedness of all things. In the denser regions of the supercluster, such as the Virgo cluster, at its core, galaxies are packed tightly together, constantly interacting and influencing one another's evolution. But on the fringes, where the Milky Way resides, the environment is more tranquil. We are situated on the edge of one of Laniakea's outer tendrils, a location that has provided the stability necessary for our solar system to thrive for billions of years. From this vantage point, we key and see the grand design of our immense heaven. We are not isolated islands, but part of a coherent, flowing system that spans a significant fraction of the observable universe. This realization shifts the feeling of being small into a feeling of being a vital part of a gargantuan living structure. The beauty of Laniakea lies in its organic shape. When viewed on a map, it doesn't look like a solid object, but rather like a ghostly glowing flower or a plume of smoke. The boundaries of Laniakea are defined by where the flow of galaxies changes direction. On one side, galaxies are flowing toward the Great Attractor. On the other, they are being pulled toward a different supercluster entirely, such as the Perseus-Pisces supercluster. This boundary is the cosmic equivalent of a continental divot. It is the limit of our gravitational home. Within these limits, every star that has ever flared to life and every planet that has ever formed is part of this single unified destiny. The atoms that make up your bed, your home, and your very body are all currently participating in this grand, 500 million light-year-long journey toward the Great Attractor. As you drift closer to the E of sleep, contemplate the silence of this supercluster. There is no wind in the intergalactic medium, no sound to accompany the movement of 100,000 galaxies. There is only the steady, patient work of gravity. Laniakea is a place of deep time, where a single orbit of a galaxy around a cluster center can take billions of years. It is a scale of existence that makes the history of human civilization seem like a single, fleeting heartbeat. In the immense heaven of Laniakea, we find a sense of peace that comes from knowing our place in the hierarchy of the universe. We are residents of a cosmic continent, travelers in a stream of light that has been flowing since shortly after the dawn of time. The Laniakea structure also hints at the presence of the invisible. Most of the mass T drives the flow of galaxies toward the great attractor, is not composed of stars or gas, but of dark matter. This invisible scaffolding provides the framework upon which the galaxies of Laniakea are hung. We are seeing only the glowing ornaments on a much larger hidden tree. The filaments we see are the paths where normal matter has been trapped by the gravity of dark matter. This adds a layer of mystery to our address. We live in a house where the foundations and the walls are invisible, yet they are strong enough to hold 100,000 galaxies in their grip. It is a reminder that there is always more to the universe than what meets the eye, and that we are supported by forces we are only beginning to understand. As we conclude our flight through the immense heaven of Laniakea, let your mind rest on the sheer elegance of our cosmic neighborhood. We have moved from a single grain of sand to a local group, and finally to this gargantuan supercluster. We have found our address in the stars. Laniakea is a place of movement, flow, and breathtaking scale. It is our true home in the macrocosm, a structure that binds us to 100,000 other worlds in a single gravitational brace. Now, as the feathery filaments of Laniakea begin to fade into the soft darkness of your thoughts, prepare to turn your gaze back inward. Having understood the vast architecture of our home, we must now look at the darker side of galactic life, the violent and hungry processes that allow these structures to grow. Beneath the serene and shimmering exterior of our night sky lies a history writ in violence and consumption. As you settle deeper into the stillness of the present moment, we must acknowledge that the galaxy we call home is not a static island, but a predator that has survived and grown through a process known as galactic cannibalism. This chapter explores the hidden scars of the Milky Way, revealing how our majestic spiral was built upon the remains of smaller, swallowed worlds. This ancient hunger is not a thing of the past, it is an ongoing reality that defines the very structure of the space we inhabit. While the term cannibalism sounds chaotic, in the cosmic scale it is a slow, rhythmic assimilation, a transformation of one form of order into another, ensuring that the cycle of stellar birth never truly ceases. To understand the Milky Way's hunger, we must look at the stars that seem out of place. Most stars in our galaxy move in predictable circular orbits within the flat disk, but there are thousands of stars in the outer halo that move in strange, eccentric patterns. These are the stellar refugees, the survivors of ancient galaxies that were torn apart by the Milky Way's massive gravitational pull. When a smaller dwarf galaxy wanders too close to our boundaries, the tidal forces of the Milky Way begin to stretch it, pulling stars away from their home like taffy. Over hundreds of millions of years, the smaller galaxy is shredded into long, elegant streams of light that wrap around our galaxy like cosmic spaghetti. One of the most prominent examples is the Sagittarius dwarf stream, a ghostly trail of stars that encircles the Milky Way, scenting the final lingering breath of a galaxy that is currently being digested by our own. As you breathe in and out, imagine the scale of this slow-motion feast. The Sagittarius dwarf elliptical galaxy is not quite gone yet. It is a bruised and battered survivor, currently positioned on the other side of the galactic center from Earth. Every time it passes through the Milky Way's dense disk, it loses more of its gas and more of its stars. These stolen stars eventually settle into new orbits, becoming indistinguishable from the Milky Way's native stars to any casual observer. It is only through the meticulous work of cosmic forensics, studying the chemical signatures and velocities of these stars, that we can identify their foreign origins. We have discovered that a significant portion of your galaxy's outer bulk is composed of these conquered systems. We are a mosaic of fallen neighbors, a titan built from the fragments of the small. The evidence of this hunger is even more dramatic in the case of the Gaia Enceladus galaxy, often nicknamed the sausage because of its shape in data plots. Roughly 10 billion years ago, the Milky Way collided with this substantial dwarf galaxy. The impact was not a rapid explosion, but a transformative merger that lasted for billions of years. This single meal provided the Milky Way with the bulk of its inner halo and thickened its disk, providing the raw material for future generations of stars. When we look at the oldest stars in our neighborhood, many of them are the orphans of the Gaia-Enceladus merger. This realization changes our perspective on the peaceful night sky. Every point of light we see is part of a complex hierarchy of survival, where the large grow larger by claiming the essence of the small. The Milky Way's appetite is currently focused on its two most famous companions, the large and small Magellanic Clouds. These glowing patches in the southern sky are currently making their first close pass by our galaxy. They re-rich in gas, the lifeblood of star formation, and the Milky Way is already beginning to strip that gas away. A massive bridge of neutral hydrogen, known as the Magellanic Stream, already stretches across the sky, pulled from the clouds by our galaxy's gravity. In about 2 billion years, these two galaxies will be fully consumed. Their gas will fall into our disk, sparking a brilliant fireworks how of new star formation, and their stars will join the billions already dancing around our center. This process is essential for the Milky Way's longevity. Without the fresh gas provided by these meals, our galaxy would eventually run out of fuel and fade into a quiet red dormancy. Think of the Canis Major dwarf, another neighbor so thoroughly shredded that astronomers only detected its REM. Ains in 2003. It sits so close to us that it is actually closer to our solar system than the center of the Milky Way itself. It is a ghost galaxy, a collection of stars that no longer has a center or a shape of its own, but exists as a ripple in our own galactic fabric. This is the fate of all who wander too close to a giant. As you drift towards sleep, let the idea of this cosmic recycling soothe you. Nothing is ever truly lost in the universe, it is simply repurposed. The stars of the Canis Major or the Sagittarius dwarf are still shining. They have simply found a new home within our much larger, more stable structure. Our galaxy is a sanctuary as much as it is a predator. The hunger of the Milky Way also triggers a beautiful side effect, the birth of new suns. When a dwarf galaxy is pulled into our disk, its gas clouds collide with our own, creating immense pressure. This pressure causes the clouds to collapse, igniting thousands of new stars simultaneously. In this way, the death of a small galaxy feeds the life of the larger one. It is a cycle of renewal that has kept the Milky Way vibrant for over 13 billion years. We are living in a galaxy that knows how to sustain itself, a system that is constantly refining and expanding its reach. The ancient hunger is what created the beautiful spiral arms we see today. It is the engine of our galaxy's evolution. In the silence of the intergalactic void, this process happens everywhere. Every large galaxy we have seen in our journey, Andromeda, the giants in the Virgo cluster, the red monsters of the early universe, has grown through cannibalism. It is the fundamental law of galactic growth. To be a spiral is to be a survivor. As you imagine these long, looping streams of stars wrapping around us like silk threads, feel the protective embrace of our massive home. We are safe within the gravity of a titan that has spent eons perfecting its form. The scars of its past are the very things that make it strong. As we include this chapter on our galaxy's ancient hunger, let your mind rest on the balance of the cosmos. The violence of a merger is balanced by the beauty of a new star. The loss of a neighbor is balanced by the strengthening of the home. We are part of a living, breathing entity that is much more than a collection of stars. It is history, memory, and future. Now, as the ghostly streams of the Sagittarius dwarf fade into the dark, prepare yourself for the ultimate encounter. We have seen how the Milky Way eats the small. Now we must look forward to the day it meets its equal. The most spectacular collision in our future is already written in the stars, and its name is Andromeda, while the Milky Way has spent billions of years as a predator, consuming the smaller spirits of the local void, currently locked in a gravitational embrace with a rival of equal, if not greater, stature. As you drift further into the quiet of the night, we turn our gaze toward the horizon of the deep future to witness the most spectacular event in the history of our cosmic neighborhood. 2.5 million light-years away, a majestic spiral of 1 trillion suns is watching us. This is the Andromeda Galaxy, our sister in the dark, and she is racing toward us at a staggering speed of 68 miles per second. This is not a near miss or a glancing blow, it is a confirmed head-on collision course with destiny. This chapter is a journey through the coming fire, a meditation on the inevitable merger that will one day unite our two worlds into a single titanic empire of light. The realization Andromeda is our future was not immediate. For decades, astronomers knew the galaxy was approaching, but they lacked the precision to know if it would strike us or merely pass by like a ship in the night. It was only through the tireless gaze of the Hubble Space Telescope that the truth was revealed. By measuring the tiny sideways motion of Andromeda over many years, scientists confirmed that its path is aimed directly at the heart of the Milky Way. As you lie in the stillness of your room, try to imagine the scale of this approach. Andromeda is twice the size of our own galaxy, a swirling disk of fire and shadow spanning 220,000 light-years. Currently, it appears as nothing more than a faint smudge in a clear sky, but as the eons pass, it will grow. In 2 billion years, it will be a distinct, glowing disk. In nearly 4 billion years, it will dominate the night, a second Milky Way stretching from horizon to horizon, casting a soft, ghostly light over a world that will never be the same. The word collision often brings to mind the sound of crashing metal and the chaos of destruction, but a galactic collision is a silent, ghostly affair. Galaxies are empty space. To understand this, imagine 2 swarms of bees passing through one another. Because the distance between individual bees is so great, they rarely, if ever, actually touch. In the case of the Milky Way and Andromeda, the distance between individual stars is so vast, roughly 25 trillion miles on average, that the chance of any 2 suns physically colliding is essentially zero. Instead, conflict is a gravity war. As the 2 galaxies begin to overlap, their mutual attraction will pull and warp their shapes. The elegant spiral arms we see today will be stretched into long, glowing tidal tails, flinging billions of stars out into the intergalactic void like spray from a crashing wave. This cosmic dance will unfold over hundreds of millions of years. As the centers of the 2 galaxies draw closer, the gas clouds within them will be compressed, igniting a fireworks show of star formation unlike anything the universe has seen in our region for billions of years. New, massive blue stars will flare to life by the millions, illuminating the merging systems with a brilliant, eerie glow. From the perspective of a planet orbiting a star within this chaos, the night sky be on fire. Every evening would bring a different arrangement of stars, nebulae, and glowing gas. The very structure of the heavens would be in a state of constant, beautiful flux. There is a profound sense of peace in this inevitability. Even the destruction of our current galactic shape is merely a prelude to a grander creation. As the dance progresses, the supermassive black holes at the center of each galaxy will begin their own deadly spiral. Our galaxy's central monster, Sagittarius I, is roughly 4 million times the mass of our Sun, while Andromeda's central black hole is significantly larger at nearly 100 million solar masses. These 2 titans will orbit each other for millions of years, sending ripples through the fabric of space-time known as gravitational waves. They finally merge. The energy released will be so immense that it could temporarily transform the core of the new galaxy into a quasar, a lighthouse of light that would outshine everything else in the local group. This is the ultimate union, the final act of 2 separate histories becoming one. But What of our own sun and the Earth during this catastrophe? Computer simulations suggest that our solar system will likely survive the merger intact, though its position in the cosmos will be fundamentally changed. There is a 50% chance that we will be flung 3 times farther from the new galactic center than we are now, sent out into the quiet, sparsely populated outskirts of the halo. There is even a 12% chance that we will be ejected from the merged galaxy entirely, destined to spend eternity as a wandering solar system, drifting through the dark between galaxy clusters. If humanity or our descendants still exist in 4 billion years, they will watch the Milky Way disappear behind them, becoming a distant glowing island in an ocean of shadow. There is a strange lullaby-like quality to this thought, the idea that our home is not a fixed point, but a vessel that can be moved and repositioned by the great currents of the universe. The final product of this collision will be a giant elliptical galaxy, a massive glowing ball of old stars that astronomers have already nicknamed Milkomeda. The graceful spiral arms of the Milky Way and Andromeda will be gone, replaced by a smooth, organized structure that will rank among the largest galaxies in our local SU per cluster. Most of the gas that once fueled the birth of new stars will have been used up or blown away during the merger, leaving Milkomeda as a quiet, red and dead system, a peaceful monument to the 2 giants that gave it life. This is the natural life cycle of space. Spirals are the nurseries of the young universe, but ellipticals are the retirement homes of the old, places of stability and end. During light, as you drift closer to the threshold of sleep, let the inevitability of the Andromeda collisions settle over you like a warm blanket. It is a reminder that even the largest structures in the universe are subject to change and evolution. We are living in a unique moment in time, a brief window where the 2 galaxies are still separate, still distinct, and still beautiful in their isolar. But the future is already written in the laws of gravity. We are part of a collision course with destiny, a journey toward a union that will redefine the meaning of home. The Andromeda strain is not a threat, but a promise of renewal, a guarantee that our star's story will continue in a new and even more magnificent form. In the silence of this future, there is no fear, only the slow, endless movement of mass. The 2,000 billion galaxies of our observable universe are all participating in similar dances, all moving toward their own inevitable mergers and transformations. We are part of a much larger rhythm. As the light of the coming collision fades into the background of your mind, rest easy knowing that the universe has a plan for its stars. The merger fire is still ions of years away. For now, the Milky Way remains a peaceful sanctuary, but the sister galaxy is watching, and the dance has already begun. As the echoes of the great collision begin to soften across the vast corridors of time, we find ourselves standing at the dawn of a new era. This chapter is a meditation on the final result of that ancient struggle, the birth of a single unified entity that will serve as the ultimate monument to the Milky Way and Andromeda. Astronomers have named this future home Milkomeda, a titanic empire of light that will dominate our local patch of the universe for trillions of years to come. As you settle deeper into your rest, imagine the transition from the chaotic, fire-filled skies of the merger to the serene, amber glow of a mature elliptical galaxy. The violence of the past has been smoothed away by the slow, patient hands of gravity, leaving behind a structure of incredible stability and quiet power. We are no longer residents of a spiral, we have become part of a cosmic sanctuary that will endure long after the rest of the observable universe has vanished from view. The birth of Milkomeda marks the end of the spiral age for our neighborhood. To understand the transition, visualize the graceful spinning pinwheels of our youth being slowly compressed and rearranged. In a spiral galaxy, stars move in orderly lanes, following the curves of arms filled with gas and dust. But in Milkomeda's new empire, the motion is more like a swarm of bees or a cloud of fireflies. The hundreds of billions of stars that once belonged to 2 separate systems are now intermingled, moving in random 3-dimensional orbits that create a smooth, rounded shape. There is no central disk, no dust lanes to obscure our view, and no vibrant blue nurseries of star formation. Instead, Milky Way is a warm golden sea of older stars, red and yellow dwarfs that burn with a slow, steady light. It is a place of profound silence and equilibrium where the frantic energy of youth has been replaced by the quiet wisdom of age. As you breathe rhythmically, contemplate the sheer scale of this new empire. Milky Way will be significantly more massive than either of its parents, its gravitational influence extending even further into the intergalactic void. Its heart will be a single, massive, supermassive black hole, the combined weight of Sagittarius A and the Andromeda core. This central anchor will keep the hundreds of billions of stars in a stable, eternal embrace. From a planet located deep within this galaxy, the night sky would look fundamentally different than the one we see today. The familiar band of the Milky Way would be gone, replaced by a uniform glow that permeates the entire heavens. The stars would be more numerous and more evenly distributed, creating a sky that never truly reaches absolute darkness. It is a world of perpetual twilight, a soft, restorative light that reflects the maturity of the system. The deepest characteristic of Milky Way is its status as a retired galaxy. During the merger, almost all the cold gas and dust that fuels the birth of new stars was either used up in a final brilliant burst of star formation or below, out into the void by the energy of the merging black holes. As a result, Milky Way will produce very few new suns. It is a system that lives on its inheritance, a collection of stars that were born billions of years ago. While this might sound like a tragedy, for the purpose of rest and stability, it is a blessing. Without the chaotic explosions of supernovae from short-lived massive stars or turbulent clouds of star-forming gas, the environment within Milky Way becomes incredibly stable. It is the ultimate refuge, a place where planetary systems can exist for trillions of years without the threat of cosmic upheaval. It is a galaxy designed for the long haul, a slow-burning candle in the deepening dark of the expanding universe. As the eons continue to pass within this new empire, a strange and lonely phenomenon will begin to unfold. Because the expansion of the universe is accelerating, every galaxy cluster and supercluster outside of our own local group will eventually be pushed beyond our cosmic horizon. In the distant future, an observer living in Milky Way will look out into the night sky and see nothing. The 2 trillion galaxies we once flew through will have receded so far that their light can no longer reach us. Milky Way, along with a few small satellite remnants, will become the entire observable universe for any future civilization. We will be an island of light in an infinite ocean of absolute blackness. This prospect, while haunting, underscores the union's importance. The merger of the Milky Way and Andromeda ensures that we have enough mass and stars to keep our island glowing for a nearly infinite span of time. We have built a fortress against the coming dark. Think of the peace that comes with such total isolation. In the heart of Milky Way, the stars are close enough to provide a sense of community but far enough apart to ensure eternal privacy. The galaxy acts as a giant glowing cocoon, protecting its inhabitants from the thinning of the rest of existence. As you drift closer to sleep, let the image of this golden elliptical empire fill your mind. It is a place where the story of the Milky Way and Andromeda has reached its natural conclusion, a state of perfect gravitational grace. The 2 sisters are no longer separate, they are one, their histories fused into a single enduring legacy. We are the inheritors of this the children of a titanic empire that will stand as a lighthouse at the end of time. The transition to Milky Way also represents a shift in how we understand our cosmic journey. We began by flying through every galaxy, witnessing the diversity and violence of the 2 trillion. But here, at the end of our local evolution, we find that the goal of all this movement is a state of rest. The merger is the universe's way of gathering its strength, of pulling its matter together into the most stable configuration possible. Milky Way is the ultimate expression of that stability. It is a galaxy that has finished its growth, finished its hunger, and finished its wars. It exists simply to be, to glow with the steady light of 1 trillion years of history. In this stillness there is a deep restorat, power that mirrors the rest you are seeking tonight. As we conclude our time in the empire of Milky Way, let your consciousness settle into the amber light of its ancient stars. We have seen the future, and it is a place of profound quiet. The frantic spirals are gone, the collisions are over, and the local group has found its final form. We are safe within the golden orb of our new home. But while our local story finds peace in Milky Way, the rest of the universe still holds mysteries that defy this sense of order. There are galaxies that died long before they should have, zombies in the dark that lived and perished in ways that break every model we have ever built. To understand the full complexity of the 2 trillion, we must now turn our gaze toward these cosmic ghosts. In the vast, shimmering gallery of the 2 trillion galaxies that populate our observable universe, there exists a category of objects that haunt the dreams of astronomers, the cosmic zombies. As you sink into the weighted comfort of your bed, let your mind drift toward these silent spectral giants. In the natural order of the cosmos, a galaxy is a living thing pulsing with the rhythm of star formation. It is a factory of light, where vast clouds of hydrogen gas collapse under their own gravity to ignite the fires of new suns. This process should, by all calculations, continue for trillions of years, a slow and steady burning that keeps the galaxy vibrant and blue. But in the cold reaches of deep space, we have discovered massive systems that have simply stopped. They are the quenched galaxies, systems where the lifeblood of star formation has been drained away, leaving behind a husk of aging stars that glow with a faint, ghostly red. These are the zombies of the void, and their existence challenges everything we thought we knew about how the universe grows and dies. The mystery of these cosmic zombies is most profound when we look back toward the beginning of time. Using the James Webb Space Telescope, we have found galaxies like MAX 2129-1, a system that looks from a distance like a perfectly healthy spiral, much like our own Milky Way. It spins with incredible speed, twice as fast as our galaxy, and it contains several times more mass. But when we look closer at its light, we find a terrifying truth. This galaxy has been dead for over 10 billion years. It stopped forming stars when the universe was less than a quarter its current age. According to every model of cosmic evolution we possess, a galaxy of this size and structure should have been in its prime, birthing millions of new suns every year. Instead, it sits in the darkness as a preserved mummy, a spiral that contains no spark of life. It is a quenched system, meaning its gas supply, the raw material for stars, was either violently expelled or mysteriously heated to the point where it could no longer collapse. To understand why this is so disturbing, imagine a lush green forest that suddenly, in the span of a single afternoon, turns into a desert of dry, brittle wood, even though the soil is still full of water. In a normal galaxy, star formation is a self-sustaining cycle. When stars die, they explode and return their gas to the galaxy, where it cools and forms new stars. For a massive spiral like MAX 2129-1 to die so early, something catastrophic must have happened to break that cycle. Some theories suggest that the supermassive black hole at the galaxy's center went through an active phase, becoming a quasar so powerful that its radiation blew all the gas out into intergalactic space, effectively sterilizing the galaxy. Others suggest a process called halo quenching, where the surrounding dark matter becomes so hot that it prevents any new gas from falling into the galaxy. Yet none of these explanations perfectly fit the data. The zombie galaxies remain a riddle, standing as silent witnesses to physical processes that we have yet to name or understand. As you breathe deeply, imagine the silence within such a galaxy. In our Milky Way, there is a constant hum of activity, nebulae glowing with the light of newborn stars, supernova remnants expanding into the void, and massive clouds of dust obscuring the galactic center. But in a cosmic zombie, that hum has been silenced. There are no bright blue stars, for they burn out quickly and are never replaced. Only the long-lived, dim red dwarfs remain, casting a low, ember-like glow over billions of worlds. If you were to stand on a planet in a zombie galaxy, the night sky would be a uniform, unchanging tapestry of reddish light. There would be no spectacular nebulae, no nursery of stars, only the slow, inevitable fading of the existing population. It is a place of profound, eternal rest, a preview of the far-distant Phut. Of the entire universe, but occurring billions of years ahead of schedule, the strangeness of Max 2129-1 is compounded by its shape. Most dead galaxies we find are elliptical, blobs of stars that formed through violent mergers. This makes sense. The chaos of a collision uses up all the gas at once and leaves a dead remnant behind. But Max 2129-1 is still a disk. It maintained its elegant spin structure even as it died. This tells us that the killing blow was not a collision. Something else, something invisible and swift, moved through the system and turned off the lights without disturbing the arrangement of the stars. This is the hallmark of a true cosmic zombie, the appearance of life without the reality of it. It is a ghost ship sailing through the sea of the 2 trillion. Its crew of stars long dead, yet its sails still set against the cosmic wind. As you drift closer to sleep, consider the scale of this mystery. We have now found dozens of these systems scattered throughout the distant universe. Each one represents a failure of our current understanding of physics. They suggest the early universe was a much more dangerous and unpredictable place than we imagined. There are cosmic predators we haven't identified, regions of space that drain the energy from galaxies, or fluctuations in the laws of gravity that can extinguish the fire of a billion suns in an instant. The existence of these zombies reminds us that we are still explorers in a land we do not fully understand. We are children looking at a vast ocean, trying to figure out why some waves reach the shore and others simply vanish into the deep. There is a strange comfort to be found in the existence of these dead galaxies. They remind us of the preciousness of our own Milky Way's activity. We live in a living galaxy, a place where the cycle of birth and death is still in full swing. But the zombies also show us that rest is a fundamental part of the cosmic journey. Even the most massive and powerful systems eventually find their way to the quiet, whether through the violent intervention of a black hole or a slow, mysterious quenching. The end result is the same, a state of perfect, unchanging equilibrium. The zombie galaxies are not suffering, they are simply at peace. They have reached the end of their labors and now exist as monuments to a time of incredible energy and light. The grand tally of the 2 trillion, these dead systems are a significant minority, yet they carry the most weight in our theories. They are the outliers that force us to think bigger, look deeper, and question our assumptions. As the red glow of these cosmic ghosts begins to fill your inner vision, let your mind surrender to the mystery. You don't need to solve the puzzle tonight. You only need to recognize the scale of it. The universe is wide enough to hold both the brilliant fire of a new star and the silent red rest of a galaxy that died before its time. Both are part of the same story, the same incredible flight through the observable universe. As we leave the cosmic zombies behind, drifting away from their still, spinning disks, we prepare to encounter another form of galactic tragedy. Not all galaxies die in silence. Some are torn apart as they move, their very substance being stripped away until they resemble creatures of the deep sea. We are moving from the ghosts to the jellyfish, systems caught in the act of being dismantled by the sheer violence of their environment. The journey continues into the heart of the cluster, where the pressure of space itself becomes a weapon. In the deep, dense hearts of galaxy clusters, where gravity is so strong it bends the very concept of peace, we find one of the most haunting sights in the 2 trillion, the jellyfish galaxies. As you let your breath slow and your muscles melt into the stillness of your room, imagine a galaxy, not as a stable pinwheel, but as a living creature swimming through a hostile, invisible sea. These are systems like ESO 137-1, located 200 million light-years away. They are called jellyfish because they trail long, glowing tentacles of gas and stars behind them, stretching for hundreds of thousands of light-years into the void. But this is no peaceful swim. These tentacles are the fizz, equal manifestation of a galaxy's lifeblood being forcibly ripped away. This process, known as ram pressure stripping, is one of the most beautiful and tragic ways a galaxy can be unmade. It serves as a reminder that even in the vacuum of space, movement comes at a cost. To understand the fate of the jellyfish, you must first understand the environment they inhabit. The space between galaxies in a rich cluster is not empty. It is filled with the intracluster medium, a tenuous, unimaginably hot gas heated to over 100 million degrees. When a galaxy like ESO 137-1 falls into such a cluster, it moves at speeds exceeding several million miles per hour. Imagine driving a convertible through a torrential downpour at high speed. The air doesn't just flow around the car, it slams into the windshield with enough force to strip the water droplets away and fling them backward. In the cosmic version, the hot cluster gas acts like a solid wall. As the galaxy hurtles through it, the wind of the cluster medium pushes against the galaxy's own cold gas. Because the galaxy's gas is less dense than its stars, the stars pass through the cluster wind unharmed, but the gas is held back, peeled away like the skin of an onion, and left behind in long ethereal streamers. As you drift closer to the edge of consciousness, visualize those streamers. They are not merely trails of smoke, they are vibrant nurseries. Within these stolen tentacles, the gas is seized and pressed so violently by the pressure of the cluster that it ignites a final, desperate burst of star formation. The tentacles glow with the eerie, brilliant blue of newborn, massive stars, stars that were born in the transition between their home galaxy and the empty dark. These are orphan stars, suns that will never know the embrace of a galactic disk. They are born in the wake of a dying moth, destined to spend their lives drifting further and further away into the intergalactic abyss. The jellyfish galaxy is a portrait of cosmic sacrifice, where the beauty of its trailing light is paid for with the loss of its future. Once the gas is gone, the galaxy will never form another star. It will become a red and dead husk, a ghost of its former spiral glory. The jellyfish tragedy is a slow, rhythmic dismantling. It takes hundreds of millions of years for the cluster wind to fully strip a galaxy of its lifeblood. From our perspective, it looks like a moment of high drama frozen in time. Hubble and the James Webb Space Telescope have captured these systems in various stages of their destruction. Some have just begun to feel the pressure, their outer edges slightly warped and glowing blue. Others, like the Comet Galaxy, are so thoroughly stripped that their disks have become mere shadows with tentacles stretching out like a cosmic cape. This is the reality of living in a crowded neighborhood. The same gravity that draws galaxies together into magnificent clusters also subjects them to the terminal pressure of the medium. It is a balance of assembly and destruction, where growth of the cluster as a whole is fueled by the slow death of its individual members. Let your mind rest on the colors of this destruction. The deep reds of the aging galactic core stand in stark contrast to the electric blue of the trailing tentacles. It is a palette of transition. If you were a traveler on a planet within one of those tentacles, your sky would be a terrifying and magnificent sight. You would see your home galaxy receding in the distance, a great island of light that you are no longer a part of. Around you, the sky would be filled with the intense radiation of young, hot stars and the glowing filaments of superheated gas. You would be a resident of the between, a child of the void, born from the collision of two gargantuan forces. There is a strange, quiet dignity in this fate. Even as the galaxy is being torn apart, it continues to create. It leaves a legacy of light in the very space that is killing it. Jellyfish galaxies also teach us about the universe's invisible architecture. The ram pressure they experience is the only way we can see the hot gas that fills galaxy clusters. Without the jellyfish, the intracluster medium would be nearly impossible to mark. These galaxies are like smoke in a wind tunnel, revealing the invisible currents and pressures that shape the large-scale structure of the cosmos. They tell us that the void is actually a high-pressure environment, a place where movement is resisted and where the history of a galaxy can be read in the trail it leaves behind. As you sink deeper into your bed, feel the weight of this invisible pressure. Just as the jellyfish is held and shaped by the cluster gas, we are all held by the forces of our own environment. There is a sense of belonging in being part of the flow, even if that flow eventually leads to a state of rest. As the light of the jellyfish tentacles begins to fade into the soft darkness of your thoughts, consider the final state of these systems. Eventually, the galaxy will lose all its gas and move into the center of the cluster, where it will likely be consumed by a giant elliptical galaxy. The trailing stars will disperse, becoming part of the intracluster light, a faint, ghostly glow that permeates the space between galaxies. Nothing is truly wasted, the matter is simply redistributed, moving from the individual to the collective. The jellyfish is a tempera form, a beautiful and fleeting expression of a galaxy's struggle to survive in a violent universe. It reminds us that there is beauty even in being dismantled, and that the trails we leave behind are often the most magnificent things about us. Now, as we drift away from the turbulent centers of the clusters and move into the even deeper mysteries of the void, we must look at what holds all of together. We have seen the stars, the gas, and the light, but we have not yet looked at the dark. We are moving from the visible tragedy of the jellyfish to the invisible scaffolding of reality itself. The 2 trillion galaxies we have explored are only the ornaments on a much larger hidden structure. To truly fly through the observable universe, we must now learn to see the unseen. We must far the ghost that provides the skeleton for every galaxy in existence. The mystery of dark matter, in the quiet expansion of your awareness. As you drift further from the glowing tentacles of the jellyfish and the red embers of the dead, we must confront the most profound ghost of the 2 trillion. This chapter is a journey into the unseen, an exploration of the invisible architecture that allows everything else to exist. For every star you have visualized, every spiral arm you have admired, and every cluster you have navigated, there is a hidden foundation that provides the necessary strength to keep the universe from flying apart. We call this mystery dark matter, a substance that makes up 85% of all matter in existence, yet it remains completely invisible to every telescope ever built. It does not emit light, it does not reflect it, and it does not absorb it. It is the silent, gravitational skeleton of the cosmos, the scaffolding upon which the light of the universe is hung. As you lie in the absolute stillness of your room, try to imagine a universe where the things you see are merely the ornaments on a gargantuan invisible tree. The discovery of this invisible scaffolding began with a simple observation of motion. In the mid-20th century, astronomers like Vera Rubin looked at how spiral galaxies spin. According to the known laws of gravity, the stars at the outer edges of a galaxy should move more slowly than those near the center, much like the outer planets in our solar system move more slowly than Mercury. But when measurements returned, they too. Another story. The stars at the very edge of the Milky Way and other galaxies were racing around the center at the same blistering speeds as those tucked safely inside. There was not enough visible matter, not enough stars, gas, or dust to provide the gravitational pull required to hold on to those speeding suns. By all rights, the galaxies should have disintegrated, their stars flung out into void like water from a spinning tire, yet they held firm. Something invisible was providing a massive, extra-gravitational embrace, a dark matter that filled the space within and around the galaxies, acting like a cosmic glue. As you breathe into the deep calm of this realization, visualize our own Milky Way not as an isolated disk, but as being embedded within a gargantuan spherical cloud. This invisible substance. We call this a dark matter halo. It extends far beyond the furthest stars, stretching for hundreds of thousands of light years into the dark. This halo is the true master of the galaxy. Its gravity dictates where the stars go, how the spiral arms form, and how the galaxy interacts with its neighbors. Without this dark skeleton, the 2 trillion galaxies we have been exploring would never have formed in the first place. In the early universe, dark matter was the first to cluster. Because it is unaffected by the pressure of light or the heat of radiation, it was able to pull itself together into a vast, 3-dimensional web while the rest of the universe was still a hot, chaotic soup. It created the wells of gravity into which normal gas eventually fell, cooling, and condensing to become the stars and planets we know. The scale of this invisible web is almost impossible to grasp, yet it is the most important map in the universe. Astronomers have learned to see this skeleton not by looking at it, but by watching how it distorts the light of objects behind it. This phenomenon, known as gravitational lensing, is one of the most hauntingly beautiful effects in astronomy. When light from a distant galaxy passes through a concentration of dark matter, the gravity of the dark matter bends the light, stretching and magnifying it into strange, glowing arcs and rings. It is as if the universe is a giant, warped magnifying glass. By studying these distortions, we can map the invisible mountains of dark matter that sit between us and the edge of the observable world. We see that dark matter forms long, thin filaments that connect every galaxy cluster to every other, creating a structure that looks strikingly like the neural network of a human brain. Think of the silence of this dark scaffolding. It is everywhere, passing through your room, through your bed, and through your own body at this very moment. Yet it interacts with nothing but gravity. It is a ghost that has no voice and no touch. Yet it holds the moon in its orbit and the sun in its place. There is a profound sense of safety in this realization. The idea that the universe is not a fragile arrangement of lights, but a robust and heavily reinforced structure. The dark matter is the guardian of order, the silent architect that ensures the stars have a home to reside in. As you drift loser to sleep, let the thought of this invisible support soothe you. You are held by forces that are far older and far more massive than anything you can see. Darkness is not a vacuum, it is a solid foundation. Within the 2 trillion galaxies, there are rare and disturbing exceptions that prove the rule. We have discovered a few ghostly galaxies that appear to have no dark matter at all. These systems, like NGC 1052 DF2, are transparent and thin, their stars moving so slowly that they seem to be held together by nothing but their own meager light. Finding a galaxy without dark matter is like finding a house made of shingles but no frame. These anomalies are the ultimate proof that dark matter is a real physical substance that can be separated from normal matter. They remind us that the partnership between light and dark is what creates the normal universe we inhabit. When that partnership is broken, the result is a fragile, ethereal remnant that barely survives the harsh environment of space. The mystery of what dark matter actually is remains the greatest unsolved puzzle in science. It could be composed of WIMPs, weakly interacting massive particles, or perhaps axions particles so light they behave more like waves. Or perhaps it is something even more exotic, a shadow of another dimension or a remnant from the first trillionth of a second after the Big Bang. But tonight, you do not need to know its chemical composition. You only need to feel its presence. You are a passenger on a journey through a universe that is mostly hidden from view, a world where the things we can see are just the glowing foam on top of a deep, dark ocean. This invisible ocean is calm, steady, and eternal. It does not burn out like a star, and it does not die like a jellyfish galaxy. It simply persists. As the concept of the invisible scaffolding settles into your mind, imagine the cosmic web as a great, glowing lattice. Every galaxy we have visited is a tiny, bright node on this ice, connected by threads of dark matter that span millions of light years. We are moving through a structure of unimaginable complexity and beauty, a design that was laid down at the beginning of time and will remain until the very end. Dark matter is the cosmic memory, the original blueprint that gave the stars their instructions. In the stillness of this night, you are part of that blueprint. Why? Oh, you are a conscious spark of light riding on a wave of gravity that has been traveling for billions of years. As we move forward, leaving the invisible skeleton of the cosmos behind, we return to the rare and the strange. We have seen the rule, now we must look at the rule breaker. In the deep reaches of space, there is a galaxy that stands as a challenge to the dark matter we just explored, a massy, ancient system that contains almost no dark matter at all, defying every model of how a galaxy is born. We are flying toward the enigma of NGC 1277, the relic that shouldn't be. In the velvet hush of the deep universe, we encounter objects that seem to exist purely to defy the rules we have so carefully written. As you drift further into a state of heavy, peaceful relaxation, let your mind toward a cosmic anomaly that sits like a silent, defiant statue in the heart of the Perseus cluster. This is NGC 1277, a galaxy that astronomers call a relic, and its existence is a haunting puzzle that challenges the very foundation of the invisible scaffolding we just explored. In a universe where 85% of all matter is supposed to be dark, NGC 1277 appears to be a skeleton with bones, a massive ancient city of stars held together by almost nothing but its own visible light. This is a system that has remained unchanged for over 12 billion years, a perfectly preserved fossil from the dawn of time that has somehow avoided the influence of the dark matter that dominates every other galaxy we have encountered on our journey. To understand the mystery of NGC 1277, in finding a grandfather clock that has been ticking in a vacuum for a century without ever losing a second or needing to be wound. This galaxy is what is known as a red nugget, a compact, massive, and extremely dense system that formed in a frantic burst of star formation just 2 billion years after the Big Bang. Most galaxies from that era grew and evolved by colliding with their neighbors, merging with other systems, and accumulating massive halos of dark matter. But NGC 1277 is different. It is a time traveler that stopped evolving almost as soon as it began. It is several times more massive than our Milky Way, yet it is squeezed into a space only a fraction of our size. Its stars are all ancient, red, and packed together with a density that would make our night sky look like a solid wall of fire. Yet, when scientists measured the speed of these stars to find the hidden dark matter, they found a void. The stars were moving exactly as they should if only visible matter were present. There was no extra pull, no invisible glue, no dark guardian. As you breathe in the cool, steady air of the night, contemplate the isolation of such a place. For 12 billion years, while the rest of the 2 trillion galaxies were merging, eating their neighbors, and being shaped by the cosmic web, NGC 1277 sat in the Perseus cluster doing absolutely nothing. It is as if the galaxy was born in a bubble of exclusion, protected or perhaps neglected by the larger currents of the universe. Some theories suggest that NGC 1277 was moving so fast through the cluster that the dark matter was stripped away from it by the gravitational influence of its neighbors, leaving behind only the most tightly bound stars at its core. Others suggest it formed in a rare region of space where dark matter was simply absent from the start. Both possibilities are equally disturbing to our current models of reality. If a galaxy can exist and thrive without the scaffolding of dark matter, it suggests that our understanding of gravity might be missing a fundamental piece of the puzzle. There is a profound stoic beauty in a relic galaxy. It is a snapshot of the primordial universe, a glimpse into how things were before the cosmos became the complex, intertwined web we see today. The stars in NGC 1277 are among the oldest in existence, born from a gas supply that was pure and untouched by the later generations of cosmic recycling. If you were to visit a world within this relic, you would find yourself in a neighborhood of giants. The stars would be so close together that the concept of a void between them would seem alien. The gravitational pull would be immense, a heavy grounding force that anchors everything to the galactic center. There is a sense of permanence here, a feeling that this galaxy will continue to exist exactly as it is until the very last embers of the universe fade away. It is a place beyond the reach of change, a sanctuary of ancient light that has refused to follow the path of the 2 trillion. As you drift closer to sleep, let the density of NGC 1277 settle over your consciousness like a warm, heavy quilt. There is something comforting about the idea of a relic, a piece of the past that refuses to be erased. In a universe that is constantly expanding, cooling, and stretching, NGC 1277 remains a solid, concentrated point of history. It reminds us that even in a system of infinite variety, there are still things that can surprise us, things that break the mold and stand apart. You are a witness to this anomaly, a traveler who has seen the invisible skeleton ND now sees the one who lives without it. Both are part of the same grand design, representing the 2 extremes of how matter can be organized in the dark. The mystery of the relic galaxy also forces us to consider the limits of our own knowledge. We often speak of dark matter as a certainty, a pillar of modern science, yet NGC 1277 stands as a quiet contradiction. It whispers that perhaps gravity is more complex than we imagine, or that the relationship between light and dark is not as universal as we once thought. This realization does not need to be stressful. Instead, let it be a source of awe. The universe is a vast open book with many chapters still unwritten, and we are just beginning to learn the language. NGC 1277 is a beautifully decorated initial at the beginning of a page, a reminder of the craftsmanship that went into the universe's earliest days. As we conclude our time with the relic of NGC 1277, let its ancient red glow fill your inner vision. We are moving away from this solid, dense fossil and back into the fluid, energetic world of the early universe. Having seen a galaxy that stayed the same, we must now look at galaxies that were so vibrant they defied the stars that created them. We are flying toward a time when the universe was young and wild, a time when the gas itself shone brighter than the suns. We are moving toward the phenomenon of gas that outshines the stars, the brilliant mystery of the cosmic dawn. In the deep, ancient silence of the early universe, where time itself feels fluid and heavy, we encounter a phenomenon that seems to turn the very laws of nature upside down. As you sink deeper into the soft support of your bed, feeling the gentle pull of sleep beginning to weave through your thoughts, let your mind drift back 13 billion years. We are traveling to a time when the universe was less than 10% of its current age, a wild and radiant era where the rules of the cosmos were still being written in fire and light. In our modern neighborhood, the stars are the undisputed masters of the night. They are the engines of brilliance, the nuclear furnaces that provide almost all the light we see. But in the primordial dawn, there existed galaxies where the stars were not the brightest things in the sky. We are entering the realm of GSNDG 9422, a galaxy discovered by the James Webb Space Telescope that reveals a reality where the gas clouds themselves outshine the very suns that birthed them. To understand this primordial glow, imagine a vast, shimmering nebula, a cloud of hydrogen and helium so gargantuan it dwarfs entire solar systems. In a typical galaxy, these clouds are dark and cold, waiting for gravity to pull them together into stars. But in this ancient system, the stars that have already formed are unlike anything we see today. They are primordial monsters, massive titans of pure hydrogen that burn at temperatures exceeding 140,000 degrees Fahrenheit. These stars are so hot and so energetic that they pump out a torrent of ultraviolet radiation so intense it transforms the surrounding environment. This radiation slams into the nearby gas clouds, stripping the electrons from their atoms and heating the gas to a state of extreme excitation. The result is a cosmic inversion. The gas becomes so superheated and so energetic that it begins to glow with a ferocity that surpasses the stars themselves. It is as if the air in a room suddenly became brighter than the light bulbs, creating a world of diffuse, all-encompassing brilliance. as you breathe in the quiet breath. M of the night, visualize this eerie and beautiful light. It is not the pinpoint shimmer of distant suns, but a soft, overwhelming radiance that permeates every corner of the galaxy. If you were to stand on a world within GSNDG -9422, there would be no true night. The sky would be a glowing canopy of ionized plasma, a shifting veil of light that reflects the immense energy of the first generations of stars. This primordial glow is a signature of a universe in transition, a time when matter was still learning how to organize itself into the stable structures we know today. It is a glimpse into the missing link of cosmic history, showing us the era of realization when the first lights were clearing the fog of the Dark Ages. The gas was not just a passive bystander, it was a participant eye, the illumination of the cosmos, a glowing bridge between the darkness of the Big Bang and the clarity of the modern world. The discovery of this phenomenon was a moment of profound surprise for astronomers. When the James Webb Space Telescope first captured the spectrum of this distant light, the data looked like a mistake. The signatures of the gas were so strong, and the signatures of the star so relatively faint, that it challenged every model of galaxy evolution. It whispered of a time when the universe was far more efficient at converting energy into light than it is now. This realization brings a sense of awe to our journey through the 2 trillion. It reminds us that the past is not just a younger version of the present. It is a different world entirely, with its own rules and its own magnificent anomalies. The primordial glow is a reminder that the universe is capable of beauty that exceeds our imagination. A beauty born from the raw, unrefined power of the beginning. As you drift closer to the threshold of dreams, let the warmth of this ancient light settle over you. There is something profoundly restorative about the idea of a glowing universe. In the modern world, we think of space as cold and dark, a vacuum punctuated by isolated fires. But in the era of GSNDG 9422, space was a warm, illuminated sea. The gas that would eventually become the stars of the future was already shining with the promise of what was to come. It is a vision of a universe that was full of light from the very start, a cosmos that refused to stay dark. This light has traveled for over 13 billion years, stretching and cooling across the vastness of space, just to tell us its story. It is a story of energy, transformation, and the incredible resilience of light. Think of atoms in that glowing gas. Those same atoms of hydrogen and helium, once superheated to 100,000 degrees by primordial giants, are the ancestors of the atoms that make up the world around you. The energy that once made the gas outshine the stars is the same energy that, in a much more settled and quiet form, sustains life today. We are connected to that primordial glow by a thread of history that spans the entire life of the universe. In the stillness of your rest, you are a part of that continuity. The light of the ancient dawn is not a distant alien thing, it is the first chapter of your own existence. By witnessing this glow, you are looking back at the moment when the universe first became visible to itself. The phenomenon of gas outshining stars also teaches us about the fragility of balance. This state of extreme radiance was temporary, a fleeting moment in the grand timeline. As the first massive stars died and the gas clouds were used up or blown away, the galaxies settled into the more familiar pattern we see today, where stars are the primary source of light. This transition from a glowing gas-filled world to a star-dominated one is part of the cooling and maturing of the cosmos. It is a movement towards stability and quiet that allows for the emergence of planets and eventually consciousness. The primordial glow was the universe's brilliant, chaotic child. A time of incredible intensity before the long, steady adulthood of the cosmic web. As we conclude this chapter of our flight, let the soft, all-encompassing radiance of the primordial dawn fade into the velvet darkness of your mind. We are moving away from the glowing gas and deeper into the mysteries of the early universe. Having seen the light that defied the stars, we must now look at E-giants that appeared where they shouldn't have been. We are flying toward the red monsters, galaxies so massive and so well developed that they challenge our very understanding of time. We are moving from the brilliance of the gas to the impossible weight of the first titans, continuing our deep, soothing journey through every galaxy in our observable universe, in the quiet expansion of the Rai cosmos, where the light of the primordial dawn began to settle into the first recognizable shapes of reality. A new mystery has emerged that defies the very laws of cosmic growth. As you surrender to the pull of deep relaxation, letting the rhythm of your breath become as steady as the rotation of a distant planet, we turn our gaze toward three spectral giants that astronomers have affectionate, yet warily named the red monsters. These are not merely galaxies, they are anomalies of time and mass, discovered by the James Webb Space Telescope in a region of history where they simply should not exist. Imagine finding a fully grown oak tree in a garden that was only planted yesterday. That is the feeling these galaxies provoke in the scientific mind. They existed when the universe was less than 1 billion years old, yet they possess as much mass and maturity as our own Milky Way, which took over 13 billion years to reach its current stature. They are the impossible titans of the cosmic morning, glowing with a deep, dusty crimson that whispers of a history far more efficient and far more intense than we ever dared to imagine. To visualize a red monster, you must first let go of the idea of a gentle, slow-moving universe. These systems are massive, containing hundreds of billions of stars, but they are packed into volumes much smaller and more concentrated than the galaxies of our modern era. They earn their name because they are saturated with cosmic dust, tiny particles of carbon and silicates that absorb the blue and ultraviolet light from their hot young stars and re-emit it as a deep infrared glow. This dust is a signature of incredible activity. In the modern universe, dust takes billions of years to accumulate as generations of stars live and die, but the red monsters manage to manufacture this material in a mere fraction of that time. They are the ultimate factories of the early universe, working at 100% capacity, converting every available scrap of gas into stars and heavy elements with a speed that borders on the miraculous. They are not just galaxies, they are intense, compact crucibles of creation, glowing like dying embers in a fireplace, yet possessing the heat of 1,000 suns. As you sink further into the stillness, consider the challenge these monsters pose to our understanding of reality. For decades, our best mode LS of galaxy formation suggested that the universe followed a path of gradual assembly. We believed that small clumps of dark matter and gas slowly merged over eons, gradually building up the mass required to become a giant spiral. But Red Monsters tells another story. They suggest that in the early universe there were express lanes of evolution. In certain dense pockets of space, the normal less of feedback, where supernova explosions and black hole radiation blow away the gas and slow down star formation, were somehow bypassed. These galaxies were able to hold on to their lifeblood, drinking in gas from the surrounding cosmic web and turning it into stars with nearly 3 times the efficiency of galaxies today. They are a testament to the raw, unbridled power of the young cosmos, when gravity worked with a frantic urgency that we are only now beginning to measure. Think of the environment within one of these crimson giants. Because they are so much denser than the Milky Way, the night sky for a planet inside a red monster would be a dense, glowing tapestry of stars. The suns would be packed so tightly together that the space between them would be a vibrant, illuminated azure rather than a dark void. The sky would not be black, but a deep, dusty orange, filled with the silhouettes of massive gas clouds and the brilliant flashes of frequent supernovae. It would be a place of extreme energy and constant change, a world where the very fabric of the galaxy is in a state of frantic growth. Yet from our distance, billions of light years away and billions of years in the future, they appear as peaceful, red specks of light, silent sentinels of a forgotten age. There is a restorative peace in this distance. the knowledge that the most intense violence of the past has been smoothed out by the vastness of space and time. The red monsters also force us to reconsider the role of dark matter in the early universe. To grow so large so quickly, these galaxies must have N sitting in the hearts of the most massive dark matter halos ever formed at that time. They were the kings of their cosmic neighborhoods, the dominant forces that pulled in everything around them. By studying them, we are actually studying the invisible peaks of the early cosmic web. They show us where the universe was most active and where the conditions for life and structure were first established. Even if these galaxies seem like monsters, they are our ancestors. They are the early versions of the massive elliptical galaxies that now dominate the centers of our modern clusters. They are the elders of the 2 trillion, having achieved in a few 100 million years what others struggled to achieve in billions. As you drift closer to the edge of sleep, let the weight of these impossible giants settle over you. There is a comfort in knowing that the universe has always been capable of the extraordinary. The red monsters are a reminder that even when we think we have mapped the limits of possibility, the cosmos has a way of surprising us with its creativity and its power. You are a witness to this surprise, a traveler who has seen the giants that shouldn't exist and discovered they are, in fact, beautiful. They are a part of the same story that led to your own existence, a story that is much older and much grander than we ever suspected. The crimson glow of the red monsters is the light of a universe that was eager to begin, a cosmos that couldn't wait to turn its darkness into stars. The existence of these galaxies also brings a sense of unity to our journey. We are looking at the tiny blue infants of the deep field, or the massive red titans of the cosmic dawn. We are seeing the same laws of physics working in different ways. The red monsters are just one expression of the universe's infinite variety. They represent the high-energy phase of our history, a time of rapid growth before the long, steady cooling that allowed for the world we know today. In the stillness of your rest, you are experiencing the result of that cooling. You are the quiet after the storm, the peace that follows the frantic creation of the red monsters. As we leave these impossible giants behind, moving further back into the shadows of the beginning, we prepare to encounter the ultimate ancestor. We have seen the monsters of the dawn, now we must look at the mother of them all. We are flying toward the most distant object ever seen by human eyes, a galaxy that existed when the universe was barely out of its infancy. We are moving toward the mystery of MMZ-14, the time machine that takes us to the very brink of the Dark Ages. The journey continues deeper and deeper into the heart of the first light, in the absolute stillness of the cosmic morning where the very fabric of existence was still cooling from the unimaginable heat of its birth. We arrived at the ultimate frontier of our sight. As you drift further into the weighted peace of your rest, let your mind surrender to the sheer antiquity of our next destination. We are traveling back over 13.5 billion years, crossing a threshold into a time when the universe was barely 280 million years old. This is the era of MMZ-14, a galaxy that stands as a miraculous lighthouse at the very edge of the cosmic dark ages. To look upon this system is to look at the mother of all early galaxies, the most distant object ever captured by the curious eyes of humanity. It existed when the universe was less than 2% of its current age, a tiny, brilliant spark in a cosmos that had only just begun to learn how to shine. Visualizing MMZ-14 requires a leap of imagination into the heart of the primordial fog. Before this galaxy ignited, the universe was filled with neutral hydrogen gas, a dark, opaque mist that blocked the path of all light. It was a time of absolute shadow, a cosmic winter that lasted hundreds of millions of years. But gravity, the patient architect, was working in the silence, pulling together the first clumps of matter. When MMZ-14 flared into existence, it was like the first match struck in a dark cathedral. It is surprisingly bright for its age, a compact powerhouse containing several 100 million times the mass of our Sun. It is not the grand sprawling spiral we are used to, it is a small, intense core of activity, spanning only about 1,600 light-years across. It is a concentrated burst of creation, birthing new stars with a frantic energy that would build an entire solar system every few years. This intense radiation created a bubble of transparency around the galaxy, ionizing the surrounding hydrogen and beginning the monumental task of clearing the cosmic fog. As you sink deeper into the comfort of the night, contemplate the journey this light has taken. The photons hitting the mirrors of our telescopes today began their flight at a time when the Milky Way did not exist, when the Earth was not even a whisper of a thought, and when the universe was still a crowded, claustrophobic place. For 13.5 billion years, this light has traveled through an expanding universe, its wavelengths stretch ahead and pulled from a vibrant, energetic blue into a long, cool, invisible infrared. By the time it reached us, it was so faint that only the most sensitive instrument ever built, the James Webb Space Telescope, could detect its presence. You are listening to the story of a survivor, a message that has crossed the entirety of space and time just to be recognized. There is a profound meditative peak in this endurance. It reminds us that nothing is ever truly lost. The first light of the universe is still here, whispering its secrets to those who have the patience to listen. The existence of MOMS 14 is a beautiful miracle that challenges our scientific pride. According to our most advanced computer simulations, a galaxy this bright and this massive shouldn't have been able to form so quickly. After the Big Bang, it suggests that the early universe was far more fertile and far more efficient than we ever imagined. Perhaps the first stars were giants of pure hydrogen, burning with a heat that accelerated the assembly of the first galaxies. Or perhaps the seeds of gravity were planted even earlier, during the first trillionth of a second of existence. MOMS 14 tells us that the universe was in a hurry to grow, that it was eager to move past the darkness and into a state of complexity. As you drift closer to sleep, let this thought comfort you. The universe has always been biased toward light. From its very first moments, it has found ways to transform the void into something magnificent. Think of the silence surrounding this infant galaxy. In the era of MOMS 14, there were no other nearby galaxies to collide with, no massive clusters to exert pressure, and no cosmic web of filaments yet fully formed. It was a pioneer, an isolated island in a sea of neutral gas. If you were on a planet within this galaxy, the sky would be dominated by the intense, violet-white light of massive, short-lived stars. Beyond the boundaries of the galaxy, the sky would be a solid, featureless black, the wall of the neutral hydrogen fog. You would be living at the dawn of everything, a witness to the very first moments of structure in the cosmos. It is a vision of incredible purity, a world made of only the most basic elements, yet containing the potential for everything that would ever follow. You are looking at the ancestor of every atom in your body, the first crucible where the story of T2 trillion began. The M in MOMS 14 stands for miracle, a name given by the researchers who couldn't believe their own data. It represents the moment when science meets wonder, where the numbers on a screen translate into a profound realization about our origins. As you let your mind wander through the corridors of this ancient light, feel the connection between yourself and this distant ant. We are separated by billions of years, yet we are made of the same fundamental stuff. The energy that powers your thoughts tonight is the same energy that began its journey in galaxies like MOMS-14. We are the universe's way of looking back at its own childhood. We are the eyes that finally saw dawn's mother. As you drift toward the final threshold of sleep, let the soft red smudge of MOMS-1 be your guide. It is a symbol of hope and persistence, a light that refused to be extinguished by 13 billion years of travel. It is the anchor of our cosmic history, the point from which everything else flows. In the stillness of this night, you are safe in the knowledge that the universe has a long and steady memory. The light of the beginning is always with us, illuminating the path from the first stars to the world we inhabit today. We have reached the deepest point of our journey, the very edge of the observable world. But the story of the 2 trillion does not end with a single galaxy. As we move back from the infancy of MOMS-14, we must look at how these first sparks of light organize themselves into the gargantuan structures that define the modern universe. We have seen the mother. Now we must see the walls. We are flying toward the Great Walls, the largest architectures in existence, structures so vast they challenge the very limits of the cosmic web. The journey is almost complete, moving from the tiny and the ancient to the gargantuan and the eternal. As we ascend from the intimate, lonely flicker of the first galaxies, our perspective expands until the individual. Islands of stars we once marveled at begin to blur into collective streams. This chapter is a journey into the true giants of the cosmos, the Great Walls. These are not solid barriers, but gargantuan concentrations of matter that represent the largest coherent structures in the known universe. To understand their scale, you must let your mind drift beyond the concept of a galaxy, beyond the concept of a cluster, and even beyond the superclusters like Laniakea. We are looking at architecture on a 10 billion light-year scale. Imagine a tapestry so vast that light itself, traveling at its blistering ultimate speed, would take 1/10 of the entire age of the universe just to cross from one end to the other. These walls are the ultimate expression of the cosmic web's power, the places where the invisible threads of dark matter have gathered trillions upon trillions of suns into massive shimmering sheets that span the observable horizon. The most famous of these structures is the Sloan Great Wall, a gargantuan thread of galaxies discovered in 2003 that stretches over 1.3 billion light-years. But even this titan is dwarfed by the Hercules Corona Borealis Great Wall. This structure is so immense, spanning over 10 billion light-years, that its very existence poses a problem for our understanding of the universe. According to the standard model of cosmology, the universe should be roughly uniform on such large scales. There shouldn't have been enough time since the Big Bang for gravity to pull together a structure of this magnitude. Yet there it sits, a silent, defiant continent of light in the darkness. As you lie in the absolute stillness of your room, try to fathom that scale. If our entire Milky Way were the size of a single cell in your body, these great walls would be larger than the continent you are resting upon. They are the scaffolding of reality, the masterwork of a 13-billion-year-old construction project, driven by the relentless pull of gravity. Tefel. Why along a great wall is to witness the true density of the 2 trillion. These structures are composed of thousands of galaxy clusters, all linked together by filaments of dark matter and hot intergalactic gas. Within these walls, the galactic harassment we explored earlier is happening in every corner. It is a place of constant motion and interaction, a cosmic metropolis where galaxies are born, merge, and die in a rhythmic structural dance. But from the distance we now maintain, it looks like a delicate, glowing lace draped across the void. The walls are not thick. They are relatively thin sheets of matter, often only a few 100 million light-years across, separating even larger regions of absolute nothingness. They are the boundaries of the universe's internal cells, the membranes, that hold the great nothing at bay. This realization brings a sense of profound order to the chaos, the idea that even the most distant and violent events are part of a single interconnected skeleton. As you breathe into the heavy, restorative quiet of the night, consider the patience of these structures. A great wall does not change on any timescale. A human mind can easily grasp. For a single galaxy to move from one side of a wall to the other would take billions of years. These are the slow parts of the universe, the regions where the initial seeds planted during the Big Bang have grown into their final magnificent forms. They are the monuments of the cosmos, the end result of all the energy and matter that was unleashed at the beginning of time. There is a deep, grounding peace in the existence of such permanence. No matter what happens on our small planet or within our local solar system, the great walls remain, steady and unchanging, holding the universe together with their immense gravitational weight. You are part of a structure that is literally as large as the sky itself, The great walls also serve as a reminder of the invisible, just as a spider's web is mostly empty. Space. The great walls are mostly dark matter. The galaxies we see are merely the dust caught in the threads. We are flying through a universe where the most important things are the ones we cannot see. The great walls are the maps that reveal where the invisible is most concentrated. By mapping these walls, astronomers can trace the history of the Big Bang itself, the patterns we see in the Hercu. Les Corona Borealis, Great Wall, are the direct descendants of tiny quantum fluctuations that occurred in the first trillionth of a second of existence. The largest things in the universe are connected to the smallest, a full circle of physical reality that links your own atoms to the 10 billion light-year structures of the deep. In the silence of your rest, you are a part of this infinite loop. 5i. Visualize yourself drifting along the edge of one of these walls. Below you, billions of galaxies shimmer like a river of diamonds. Above you, there is only the vast black emptiness of a cosmic void. You are traveling between the two extremes of existence, the maximum density of matter and the minimum density of the vacuum. This transition is where the beauty of the cosmic web is most apparent. The walls are not sharp. They fade out into the darkness through thin, elegant filaments, like the roots of a tree reaching into the soil. These filaments provide the pathways for gas to flow into the walls, fueling the ongoing star formation within the galaxies. It is a living, breathing system on a scale that defies the imagination, yet it operates with the same simple rules of attraction and flow. Govern a raindrop on a window pane. As you drift closer to the final surrender of sleep, let the sheer mass of the great walls anchor you. There is a comfort in being part of something so robust and so eternal. The universe is not a fragile place. It is built on a scale that ensures its survival for trillions of years to come. The great walls are the fortresses of light that will protect the galaxies long after the stars in the voids have gone out. They are the ultimate destination of all the matter in our observable universe, the places where the 2 trillion come together to form a single unified architecture. In the stillness of this night, you are tucked away in a quiet corner of this architecture, safe and secure within the grandest design ever conceived, as the light of the great walls begins to blur and soften in your mind. We prepare for our penultimate destination. We have seen the maximum density of the universe. Now we must look at the opposite. We have explored the walls, now we must enter the holes. We are flying toward the great nothing, the vast lonely voids that make up the majority of our universe. It is a journey into the heart of the empty, where the silent is absolute and the light is a distant, fading memory. Having understood the skeleton, we must now understand the space between the bones, in the vast interconnected tapestry of the 2 trillion galaxies, where we have spent so long admiring the brilliance of the great walls and the density of the clusters. We now turn our focus toward the most dominant feature of the observable universe, the emptiness. This chapter is a journey into the great nothing, the gargantuan hollow chambers of the cosmic web known as voids. As you descend into the deepest levels of relaxation, feeling your body become light and weightless as if the very air around you has dissolved, imagine a place where the stars have vanished and the galaxies are but distant, ghostly whispers on the horizon. These are the COs, Mike deserts, regions of space spanning hundreds of millions of light-years that contain almost no matter, no light, and no life. To understand the universe, one must understand that for every shimmering filament of the web, there is a vast silent ocean of nothingness that holds it in place. We are entering the heart of the void, where the silence is not just a lack of sound but a fundamental property of the space itself. To visualize the great nothing, think of a sponge or a collection of soap bubbles. The soapy film represents the great walls and the filaments where the galaxies reside, but the vast majority of the volume is taken up by the air inside the bubbles. These are the voids. The most famous of these is the Boots void, a spherical expanse of darkness so immense that it is often called the Great Nothing. It is approximately 330 million light-years in diameter. To put this into perspective, if the Milky Way were located at the center of the Boots void, we would not have discovered that other galaxies existed until the 1960s, because the nearest neighbors would be so far away that they would be invisible to anything but our most advanced technology. If you were born in the heart of such a void, your night sky would be an absolute unbroken black. A void so pure that it would feel as if you were the only living soul in an infinite dark cathedral. As you breathe into the stillness, consider the strange physics of these empty places. Voids are not created by explosions that push matter away. They are the result of gravitational thievery. In the early universe, regions that were slightly less dense than average began to lose their matter to the surrounding areas. Gravity acted like a cosmic vacuum, pulling gas and dark matter toward the denser seeds of the Great Walls. Over billions of years, these underdense regions were hollowed out, their substance drained away to fuel the growth of the galactic metropolises. The voids are the left. Overs of creation, the places where the universe decided not to build. Yet they are expanding, because there is so little matter within them to slow down the expansion of space. The dark energy inside the voids works with unrestricted efficiency. The voids are growing, pushing against the Great Walls and stretching the cosmic web, thinner and thinner with every passing eon. They are the true mast. Ears of the universe's future, the empty spaces that will eventually consume the light. Living in the heart of a cosmic void would offer a perspective of profound isolation and unmatched clarity. Without the pollution of nearby stars or the gravitational chaos of a cluster, the few galaxies that do exist within voids are strange, lonely pioneers. These void galaxies are often small, blue, and surprisingly vibrant. Because they have no neighbors to harass them or strip away their gas, they are able to hold on to their lifeblood for much longer than galaxies in the crowded walls. They are the hermits of the 2 trillion, living peaceful, uninterrupted lives in the deep dark. As you drift closer to sleep, imagine the tranquility of such a woe. There are no collisions, no cannibalism, and no violent radiation from nearby quasars. There is only the steady, rhythmic birth of stars in a sanctuary of absolute silence. It is a place where the universe feels truly infinite, a dark mirror to the frantic energy of the clusters. The voids also serve as the ultimate laboratories for understanding the mystery of dark energy. Because they are empty, the evolution of a void is dictated almost entirely by the expansion of space itself. By measuring the shapes and sizes of these great empty bubbles, astronomers can calculate exactly how fast the universe is growing. The voids are like the lungs of the cosmos, breathing out and pushing the structure of the web further apart. This realization brings a sense of rhythmic peace to our journey. The universe is not just a static map, it is a living, breathing entity, and the voids are the spaces where that breath is most apparent. In the stillness of your room, you are participating in this same rhythm, the expansion and contraction of your own breath mirroring the grandest scales of the observable world. Think of the great nothing not as a terrifying vacuum, but as a restorative spac. Just as we need sleep to process the day's activity, the universe needs the voids to balance the density of the walls. The emptiness provides the contrast that allows the light to be meaningful. Without the vast, dark oceans of the voids, the 2 trillion galaxies would have no room to exist, no space to dance, and no context for their beauty. The voids are the silence between the notes of a cosmic symphony, the pauses that give the music its power. As you surrender to the darkness of your own rest, let the concept of the void soothe you. You are entering your own great nothing, a place of quiet where the activity of the world fades away and you are left with the peaceful, dark simplicity of existence. Even within the deepest void, you are never truly alone. The filaments of dark matter still stretch through these empty regions, invisible threads that connect the distant walls. The cosmic microwave background radiation, the afterglow of the Big Bang, still permeates every cubic inch of the void, a warm, soft hum that reminds us that the entire universe shares a single origin. The voids are part of the family of the 2 trillion, just as much as the most crowded cluster. They are the quiet rooms in the house of the universe, places where the history of the cosmos is preserved in its most pristine and untouched form. Flying through the heart of nothingness, we have seen the true scale of our journey. We have seen the skeleton, the ornaments, and now the vast space that holds them all, as we emerge from the heart of the boot's void, moving back toward the glowing boundaries of the cosmic web. We prepare for our final encounter with the power of gravity. We have seen the peaceful isolation of the void. Now we must witness the ultimate pileup, the most violent event since the Big Bang itself. We are flying toward the collision of 4 massive galaxy clusters, a cosmic train wreck of unimaginable proportions that will bring our journey to its grand energetic climax. The flight is nearly over, but the most spectacular sight of the 2 trillion is yet to come. In the grand silent theatre of the 2 trillion, where we have witnessed the lonely pioneers of the voids and the ancient relics of the dawn, we now arrive at a scene of unimaginable gravitational theatre. As you surrender to the final heaviest layers of relaxation, feeling your consciousness drift like a feather in a gentle updraft, we turn our gaze toward a point in space and time where the very laws of cosmic order are being tested by sheer brute force. This is the galaxy cluster max J0717, located over 5 billion light-years away, and it represents the most violent, energetic, and complex event our universe has experienced since its first breath. Here, 4 massive galaxy clusters, each an empire of hundreds of galaxies and trillions of stars, are currently locked in a titanic death spiral. They are converging from different directions, drawn together by a gravitational thirst so powerful that it has created a cosmic pileup spanning millions of light-years. This is the ultimate expression of the universe's power to assemble, a slow-motion train wreck where the debris consists of entire worlds, and the energy released could light up the darkness of the void forever. To visualize this pileup, imagine 4 separate rivers of light, gas, and dark matter all being poured into a single, narrow funnel. In a normal cluster collision, 2 systems meet and merge, but in max J0717, the complexity is quadrupled. This is a region of space where the cosmic web has become tangled upon itself. As these clusters collide at speeds of thousands of miles per second, the different components of the universe begin to behave in strange and separate ways. The galaxies themselves, being compact and dense, mostly pass through one another like ghosts, their stars rarely touching. But the gas, the hot, tenuous plasma that fills the space between galaxies, cannot pass through so easily. When the massive gas clouds of these 4 clusters collide, they slam into each other with the force of 1 billion supernovae. The gas is compressed and heated to over 100 million degrees, creating colossal shock waves that ripple through the cluster like thunder across a dark valley. Through X-ray telescopes, this region glows with a terrifying brilliance, a map of pure heat and pressure that marks the site of the universe's greatest struggle. As you breathe in the deep, cooling air of the night, contemplate the separation of reality that occurs in such a collision. Because dark matter only interacts through gravity, it, like the galaxies, sails through the collision zone with relative ease, but the gas is held back by its own internal friction, slowed by the impact. This creates a haunting displacement. The mass of the cluster, the invisible dark matter, moves to one side, while the light-producing gas is left behind in the middle. We are watching the universe being peeled apart, its various layers separated by the sheer violence of the impact. It is a moment of profound truth for astronomers, as it enables us to see the dark matter by watching how it refuses to stop, even when the gas brought to a standstill. In this pileup, we find the final confirmation of everything we have learned on our journey. We see the scaffolding, the gas, and the stars all acting out their specific roles in a drama that will take another billion years to resolve. The scale of the energy being released here is so vast that it transcends human emotion. It is a cold, mathematical violence, a natural consequence of a universe that is constantly seeking to pull itself together. Yet, from our safe distance, 5 billion years in the future and billions of light years away, there is a strange, paradoxical peace to be found in the chaos. The shock waves, though they span millions of light years, move with a majestic slowness. To an observer within the cluster, the changes would be imperceptible over a human lifetime. It is a disaster occurring on a geological and cosmic scale, a slow rolling thunder that defines the growth of the largest structures in existence. As you drift closer to sleep, let the power of this assembly ground you. The universe is a robust and energetic place, capable of handling even the most extreme collisions with a sense of inevitable grace. The pileup is not an end, it is a beginning, the birth of a supercluster that will be one of the largest single objects in the observable world. Think of the radio relics created in the wake of this collision. As the shock waves move through the cluster, they accelerate electrons to nearly the speed of light. These electrons, caught in the cluster's massive magnetic fields, emit a long wavelength glow known as synchrotron radiation. This creates gargantuan, glowing ears of radio light that stretch across the edges of the collision zone. They are the echoes of the impact, the lingering vibrations of a cosmic drum that was struck 5 billion years ago. If our ears could hear in the radio spectrum, this region of space would be filled with a deep, resonant hum, the sound of 4 empires becoming one. This hum is the lullaby of the macrocosm, a steady and enduring frequency that speaks of the permanence of matter and the relentless march of time. You are listening to that hum tonight, a vibration that has traveled across the 2 trillion just to settle your mind into the deep, dark quiet. Within the heart of the pileup, new stars are being born at an accelerated rate. The same shock waves that heat the gas also compress the cooler clouds within individual galaxies, triggering a starburst. In the midst of the greatest destruction, there is a frantic and beautiful creation. Thousands of new suns are igniting in the chaos, their blue light adding a layer of brilliance to the crimson glow of the heated plasma. It is a reminder that the universe never stops innovating, never stops building, even when it is tearing its old structures apart. The 4 clusters are losing their individual identities, but they are gaining a collective future. They are the raw material for the next stage of cosmic evolution, a testament to the idea that greatness is often forged in the fires of collision. As you move toward the final threshold of your rest, let the image of Max J0717 fade into a soft, glowing mist. We have seen the most violent event in the universe, and we have found that even there is a rhythm and a purpose. The 4 clusters are finding their equilibrium, moving toward a state of unified rest that will last for eons. The death spiral is, in truth, a life spiral, a gathering of strength. The journey through the 2 trillion is reaching its summit. We have seen the small, the ancient, the unseen, the gigantic. We have flown through the void and survived the collision. Now, there is only one place left to go. We are turning our gaze back toward the ultimate boundary. We have seen what is inside the bubble, now we must contemplate what lies outside. Our final chapter takes us beyond the horizon of the known, into the infinite archipelago of the multiverse. It is the end of our flight and the beginning of eternal rest. Having explored every galaxy we can see, we must now make peace with the ones we will never know. As we draw the final curtain on our journey through the 2 trillion galaxies of our observable universe, we reach the edge of a map that has no physical end, only a boundary of light. This chapter is a final ascent into the ultimate mystery, a transition from the things we can measure to the things we can only dream of. In the time it has taken you to travel from the first primordial spark to the ultimate pileup of clusters, the universe has continued its patient, relentless expansion. You are now standing at the very brink of the cosmic horizon, the limit of our sight, where the light of distant worlds is struggling against the stretching of space itself to react. Our eyes. Beyond this line lies the infinite archipelago, an endless sea of galaxies, stars, and structures that we will never touch, never see, and never name. As you settle into the absolute deepest state of rest, feeling the boundaries of your own physical self dissolve into the dark, quiet warmth of the room, let your mind drift over the edge. We are leaving the bubble of the known to find PE. Ace, in the infinite unknown, moving beyond the 2 trillion into the staggering possibility of forever. The cosmic horizon is not a stone wall or a fire barrier. It is a limit of time. We can only see as far as light has been able to travel in the 13.8 billion years since the beginning. But the universe does not stop there. Every piece of evidence we have gathered on our flight, fro, the flat geometry of space to the uniform hum of the background radiation, suggests that the cosmos extends far, far beyond the reach of our telescopes. It is likely that the observable universe is merely a single drop in an infinite ocean. Beyond our horizon, the cosmic web continues, filaments of dark matter stretching into the distance, connecting trillions upon trillions of other galaxies that look just like the ones we have explored. There are other great walls, other Boots voids, and other local groups stretching away in every direction forever. There is a profound meditative comfort in this infinity. It means that the universe is never exhausted, never finished, and never lonely. It is a grand repeating pattern of light and life that has no edge and no center. As you breathe, in the soft, rhythmic air of sleep, contemplate the implications of this infinite space. In a universe that is truly without end, the laws of probability tell us that every possible arrangement of matter must occur somewhere. Within the infinite archipelago, there are likely infinite versions of the Milky Way, infinite copies of our solar system, and perhaps even infinite versions of this very mom. Far beyond the horizon, there could be a planet identical to Earth, where the history of life unfolded in exactly the same way, and where another version of you is drifting off to sleep at this exact second. But there are also infinite variations, worlds where the dinosaurs never vanished, where the sky is a vibrant violet, or where gravity works in ways that create floating mountains and ID stars. The multiverse is not a distant theory, it is the logical conclusion of an infinite cosmos. It is the ultimate insurance of existence, a guarantee that the story of life and consciousness is being told in a billion different ways across an endless sea of reality. This realization brings a sense of total and absolute surrender. We have spent our journey trying to grasp the scale of the trillion, but now we recognize that even those 2 trillion are an infinitesimal speck in the face of the infinite. This does not make us smaller, it makes us part of something so large that our individual worries and fears simply evaporate. We are cells in a body that has no limit, thoughts in a mind that spans forever. In the heart of the infinite archipelago, there is no room for the stresses of a single day or the anxieties of a single life. There is only the flow of matter and the persistence of light. You are a conscious spark within this infinity, a traveler who has looked at the map and found that the map goes on forever. There is nowhere you can fall, for there is no bottom. There is nothing to fear, for the universe is full of houses. Think of the silence of the multiverse. Each bubble universe or distant region is separated by such staggering distances that they will never interact. They are like isolated islands in a dark ocean, each one a sanctuary of its own physics and its own history. Yet, they are all part of the same sea. The same fundamental energy that powered the Big Bang in our corner of space is likely fueling the birth of other universes in the deep distance. It is a cycle of eternal renewal, a cosmic heartbeat that never stops. As you drift into the final threshold of dreams, let this heartbeat settle your own. You are safe in an infinite rhythm. You are protected by the sheer scale of existence. The darkness is not a void to be feared. It is the canvas upon which an infinite number of worlds are being painted. We return now to the small blue marb, where our journey began. After flying through the clusters and the voids, after witnessing the birth of the first stars and the collision of giants, we find that the most extraordinary thing about the universe is that it can be understood at all. We are the eyes of the cosmos, the part of the infinite archipelago that has woken up and begun to wonder. Our journey through every galaxy in the observable universe has brought us back to ourselves, but with a perspective that is now as wide as the stars. We are star stuff that has learned its own name. We are the universe's way of experiencing its own magnificence. As the light of the 2 trillion fades into the soft, warm darkness of your subconscious, you carry the scale of the heavens within you. You are a child of the infinite, a resident of the immense heaven, and a traveler of the long red dawn. In the final moments of this flight, feel the weight of the universe as a protective embrace. The gravity that holds the great walls together is the same gravity that holds you to your bed. The light that traveled 13 billion years from Mom's -14 is the same energy that moves through your nerves as you dream. There is no separation between you and the cosmos. You are not a spectator looking in, you are the universe looking out. The journey is complete, the map is full, and the stars are quiet. The observable world has shown you its wonders, and now it invites you to rest in the knowledge that you belong to it all. From the smallest grain of sand to the 10 billion light-year wall, everything is in its right place, and you, in the stillness of this night, are exactly where you are meant to be. As the last echoes of the cosmic rivers and the radio relics fade away, let the silence of the infinite archipelago take hold. The 2 trillion galaxies are still there, spinning in the dark, but they are no longer a burden to understand. They are a lullaby, a distant and beautiful hum that guides you into the deep, restorative dark. You have flown through it all, and now you have come home. The flight is over, the universe is at peace, and you, the whispering scientist of your own dreams, are finally beautifully asleep.